In this, our penultimate episode on simplification, we're going to look at the last method used to expand brackets. And then in the next episode, we're going to look at challenging questions where a number of methods are put together into one problem. So click on that subscribe button to make sure that you do get that last one, which will be really helpful for exams and tests. And just remember that all of my series go through from the very, very basics of a section right through to the challenging questions. And in this way, you can actually teach yourself from the basics right through to the tricky ones. So looking at the first one, because we've got a binomial times a trinomial now, if it was a binomial times a binomial, we learnt about FOIL, which meant first, outers, inners, lasts. And that was the way that we distributed every term in this bracket with every term in that bracket. But now, because we've got three terms in the second bracket, it becomes a bit longer because we have to say this one times the first one, then times the second one, and then times the third one. And then when we finish that, distributing that one across, we need to distribute that times that times that, and that times that. So we've actually got 6 different combinations that we're doing. So let's start by saying 2a times 4a squared is 8a cubed. 2a times 6ab is 12a squared b. 2a times 9b squared is 18ab squared. Finished with the 2, we go on to this. Be careful, it's got a negative sign in front of it. So negative times positive is negative 12a squared b. Negative times positive is negative 18ab squared. And negative times positive is negative 27b cubed. So we've ended up with 6 terms. We need to look for like terms. A squared b and a squared b, ab squared and ab squared. This term has no like terms, so we simply write it down as it is. We've got 12a squared b minus 12a squared b. When we subtract something from the exact same thing, we're left with 0, which means this term, this a squared b term, has disappeared. 18ab squared minus 18ab squared, the same things happen. That term has disappeared, and I'm left with minus 27b cubed. Now, if you look at that answer, and if you went through the series on factorization, you should recognize that answer as being the difference between two perfect cubes. And if we'd been asked to factorize that, we would have ended up with something like that, a binomial times a trinomial. So let's leave that one as it is, and let's go on to this one to see if a similar thing is going to happen. So again, I've got to multiply each, etc. I'm not going to put all the loops in. So 3x times 4x squared is going to give me 12x cubed. 3x times negative 8xy is going to give me negative 24x squared y. That times that is going to give me 21xy squared. Now we move on to the second term. Negative times positive is negative 8x squared y. Negative times negative is positive 16xy squared. And that times that is going to give me negative 14y cubed. Right, so have we got like terms? X squared y, x squared y, xy squared, xy squared. So my 12x cubed is going to stay as it is. Negative 24 minus 8 is negative 32x squared y. 21 plus 16 is going to give me positive 37xy squared, and that term is going to stay exactly as it was. So why have I ended up with 2 terms, a difference of 2 perfect cubes is my answer here, and here I've ended up with 4 terms. And this is the very important thing to look at right at the very beginning. If you remember this technique for finding out whether you're going to end up with something like that or something like that, then you can alleviate this long step in many circumstances. So let's look at what's going on here. The square of 2a is 4a squared. 3b all squared is 9b squared. And if we think back to our rules for factorizing the difference of two cubes, whatever that sign is, that would be the opposite, and then the product of these two, multiplying them together, would give me that. So here I can see that this is a perfect square trinomial, and therefore I'm going to end up with a difference of two cubes, so I don't need to do that step. Let's have a look here. If I square 3x, I would get 9x squared. That's not that. If I squared that, I would get 4y squared. So that's not that. So this is not a perfect square trinomial. In this case, I have to multiply out all 6 terms and then gather like terms. So before we start the last one, let's be clever and just stop for a minute and decide whether we need to do that second step or not. So 4m all squared would give me 16m squared. 5n all squared would give me 25n squared. Is this the opposite of that sign? Yes, it is. What's the product of these two? 20mn, yes. So I'm sitting with this situation, which means my answer is going to be a difference of two perfect cubes, which means all I've got to do is multiply the firsts and multiply the last, because the others would all disappear. So 4m times 16m squared is 64m cubed. Just like that sign there, translated down to the bottom, this sign here is also going to become the same sign in the answer, and that term squared will give me 25n cubed. So in this one we ended up with an answer which was a difference of two perfect cubes. This one we've got a sum of two perfect cubes. And I've made a very silly mistake. I hope you're all shouting at me and saying, look what you've done. 5 times 25 is 125n cubed. How important it is always to just look back at what you've written, because often in our minds or out loud we say one number and we write another number down. So always double check at the end. I hope that has been helpful, and I hope I'm going to see you in the final episode of Simplification.